here's my integrated math 1, chapter 1 study guide. I'm just gonna go through it for you guys. So first part of the chapter was solving linear equations. So we're gonna solve this. Remember, whatever you do to one side, you want to do to the other side, and we want to do inverse operations and cancel things out. So this first one, here's my equal sign. And I want to get the x by itself, so do that. We're gonna get rid of that 9. Right now it's plus 9, so we're gonna do minus 9 to both sides. What I do to the left, I gotta do to the right. We get x is equal to 15 minus 9 is 6. Over here, same concept, but now it's the two-step equation. I need to get rid of the 3 first. A lot of people want to divide by 4, which you want to get rid of the x's first. So this is the last thing you're going to do. So get rid of this guy first. So get rid of that. It's minus. We're going to go plus 3. These cancel out. We're left with 4x on this side equals 17 plus 3 is 20. And we just divide both sides by 4. We get x is equal to 5. There we go. This one, a little more complicated. So the first thing I'm going to do, well, first, anything that's on the same side, you want to simplify first. I'm not going to, I mean, you can subtract 5, but you want to, let's work on simplifying the side first. So I got to distribute. We're going to multiply this 3 by both of these. So I get 3x minus 6 plus 5 equals 14. And then again, before I do anything else, I want to add like terms. So I can add these two because they're both on the same side. I'm not going to go plus. A lot of people tend to do like plus 6. I'm like, what's going on? You just want to add things on the same side first. So I could add these two. Negative 6 plus 5 is negative 1. We're at 5 when we go back 6. So that's going to get me negative 1. I still have the 3x and the 14. And now it's like a normal problem. To get rid of the minus 1, we're going to add 1 to both sides. Here's my divide. All right, whatever I do to the left side, I do the right side. And I get 3x is equal to 15. Divide by 3, x is equal to 5. Moving on. Slightly more complicated, but same concept in general. We're going to distribute this 2 to both of these. I'm going to get 6x plus 2. We still have the negative x equals 22. And before I do anything else, I want to combine like terms. So I'm not going to plus x plus x. They're on the same side, so you just combine like terms. So we're just going to add this guy plus this side. Again, they're on the same side. So we're just going to add them. And you get 5x. 6x minus 1x is 5x. Plus 2 still there equals 22. And then we're just going to solve it. So minus 2, that's going to get me 5x. These are gone. Equals 20. Then we divide by 5. X is equal to 4. Over here, same concept. Now, if you want, you can actually divide both sides by 4 first. A little bit more pro move. But I'm going to go in the more common way. I'm going to distribute this to both sides. Negative 4x plus 12 equals 20. Negative 4 times negative 3, positive 12. Negative times a negative, and negative 4 times x equals that. Again, we're just going to solve it. So get rid of that 12 first. Minus 12 minus 12. We're left with negative 4x is equal to 8. 20 minus 12 is 8. And then we're just going to divide by negative 4. We're going to get x is equal to negative 2. Now, if you want, this is a test, so you can always check your work. So if I want to check my work, I have negative 4 times negative 2 minus 3 equals 20. So again, it is a test. You always want to make sure you get 100. You check your work. Combine these two, I get negative 5. Negative 4 times negative 5 does equal 20, so it does work. Checks out. So again, you can always check your work if you want. Just plug your answer back into the equation, see if it checks out. So that's the first section. Let's move on to the second section. Now we're going to have variables on both sides. The key thing is you want to make it look like what we just did. So how do you do that? Well, you want to eliminate the smaller variable first. So if you have variables on both sides, eliminate the smaller variable first. So subtract that from both sides or add it to both sides. If both variables tend to cancel out, then you have two options. If it's a true statement, you have infinitely many solutions. If it's a false statement, like 0 equals 6, then you have no solution. So if the variables cancel out, it's either infinitely many solutions if it's a true statement, and if it's a false statement, you have no solution. So let's do these. And just real quick, again, I like to get rid of the smaller variable first. So here's 2x. I'm going to subtract 2x from the sides. If I subtract it from here, I have to subtract it from the x, right? X's go with x's. So minus 2x from here, I get 3x minus 3 equals 12. And now it's like every other problem we just did. So we solve it. We're going to go plus 3 to both sides. I'm going to get 3x is equal to 15. Then we're going to divide both sides by 3. Let me get x is equal to 5. And again, if you want, you can check your work. There we go. The next one, so to solve this, I'm going to distribute. I get 4x plus 4 is equal to 4x plus 4. If you notice, they're exactly the same. You can stop there. You go like, oh, this is all real numbers, infinitely many solutions. Because if you want, you can subtract 4x from both sides to show it. But they're the same thing. So this is a true statement. We have infinitely many solutions, or all real numbers. Like that. over here. Now in this one, they're not the same, but if we look at them, we solve it. They're both the same, but let's get rid of one of them. Negative 3x minus 3x. Those cancel, and I'm left with 7 is equal to negative 2. That's a false statement. That's not true. So no solution. Or I should probably circle one solution because there's only one answer there. The one right here, this x's are different, so I'm going to have a solution. I could solve it. So let's solve it. Again, I like to get rid of the smaller variable first. Minus 3x from both sides. And I get 4x minus 10 equals 2. I'm going to add 10 to both sides. 4x is equal to 12. Divide by 4. X is equal to 3. So there you go. How to solve equation variables on both sides. Next are little equations, which people tend to hate. The basic idea is you solve for the variable that you want, and you treat everything else like a number, just like the ones we just did there. Move stuff around, divide it, treat everything like a number. Okay, so the first one, I want to get w by itself. So I'm trying to get this guy by itself. So first I gotta get rid of these two, 2l. So we're gonna subtract 2l from both sides. And the key here is that you just gotta be able to accept it. So p minus 2l, I can't do anything. So just leave it as p minus 2l equals 2w. Now I want to get rid of the 2, get the w by itself. So we're going to divide by it, right? Right now it's being multiplied by w, so we're going to do the opposite. We're going to divide. And I'm going to get w equals p minus 2l over 2. Or if you want to be a little more slick about it, you could divide each term by 2. And you got p over 2 minus l. Either way is fine. I'd say either answer. They're both technically correct. This one's a little nicer though. Next one, I want to solve for h. Well, right now, h is being multiplied by L and W. Opposite of multiplying, dividing. So let's do that. Don't overthink it. Just got to divide by both of these. And we get V over LW equals H. So that's the key. Just treat all the variables like numbers. Let's do a few more. This one you're going to see a lot in the school year. So we want to get the y by itself in this case. So I want to get the y by itself. So I got to get rid of that 3x. And right now it's being added to the y. So do the opposite. Subtract it from the y. And again, the key thing is you got to let it be. I can't subtract. This is not 6. This has an x that doesn't. You just got to let it be. 9 minus 3x. And that's good. In the future, we'll put the x in front, but for what we're doing today, that's fine. Over here, kind of like the one we did above, we're trying to get the r by itself. Well, right now it's being multiplied by 2 pi. People freak out when they see the pi. Nothing to freak out about. It's the same concept. I want to get the r by itself. It's being multiplied by 2 and pi, so do the opposite. Divide by 2 and pi. Those cancel, and you get c over 2 pi equals r. And there we go. Okay, so that was literal equations. Next up, let's solve on a number line. So very similar to solving the linear equation, but now we got to graph it afterwards. The one where we got to remember, you flipped an inequality sign whenever you multiply or divide by a negative number. Other than that, you treat it pretty much like normal. So this first one here, let's try to get that x by itself. I'm going to add 5 to both sides and get 2x is greater than 14. Then we divide by 2, and we get x is greater than 7. So now I draw the number line. Here is 7 right here. It is an open circle. And then we want numbers that are greater than 7. Numbers greater than 7 are to the right. Greater than is generally to the right, less than to the left. And if you're not sure, it kind of tells you by the little arrow. Go that way. If you have improper notation, which is variable on the left-hand side. There you go. That's my graph. Next one, same idea. And by the way, I should point out in case we're not sure. Remember the way the circles go, open circles, if you cannot be the number greater than or less than solely. And if you can be the number with an equal to sign, then it's a closed circle. So the last one was open because it's just greater than. The next one's going to be a closed circle. So we got to solve this one. Again, you can do this lots of ways. You can just divide by -3 first, or you can distribute. I think most people prefer to distribute, so I'll do that. And then we still have less than 15, less than equal to 15. We want to get the x by itself, so remember to do that. You get rid of the other thing first. Get rid of this guy first. So plus 6 plus 6. I get -3x is less than 21, negative divide by -3. And remember the one rule we have that makes it different is if you divide by negative or multiply by negative, you got to flip the inequality, so it should be greater than -7. Just like that. 21 divided by -3 is -7. So here's -7, close circle, and we are going to go to the right again. Yeah. Remember, you also draw on the actual number line if you want. It's your choice. I always find it easier to see if it was above it. Okay, next one. Similarly, we're going to solve this. Here's my line. I'm going to subtract 5 from both sides. I get -2x is greater than or equal to 8. And we're going to divide by negative again. Divide by -2. So I'm going to get x. We're going to flip that inequality. Less than or equal to, and I get -4. So x is less than or equal to -4. Here's -4. Close circle. I'm going to go to the left this time. if you have proper notation, it kind of points in the right direction. So there we go. That's inequalities. Let's do compound inequalities and an or. So this first one here is an and statement. So the trick to this one is whatever you do to the left side, you gotta do whatever you do to one side, you gotta do to all three sides. Remember, and we're looking for the overlap. We're looking for things crossing the overlap, or take either side. So this first one though, I want to get rid of that 2 because I want the x by itself. So we're gonna minus 2 from everything. So 2 from there, 2 from there, 2 from there. I get -6, 2x, and -12. Inequalities stay where they are, and then we got to get rid of that 2, so let's divide everything by 2. So I'm gonna get -3, -6 divided by 2. It's still less than. Remember, we're dividing by positive, so nothing changes. You have x because those cancel, and it's less than negative. So why did I make it negative? Positive. Okay. Whew. Let's correct that. This should be 8, 10 minus 2, and I should get divided by 2 is 4. I thought it was -10 for some reason, but anyway, so this is what we get. That's the correct answer. Glad I saw. That's kind of embarrassing. And this side should be equal to also. So watch, don't make silly mistakes like me. So here we go. So this is one of my favorite things to graph on a number line. They're telling x is between -3 and 4. So all we're gonna do is my lower bound is -3, open circle there. My upper bound is 4, close circle there. And your x, which is a line, is between the two. There you go. X is between -3 and 4. Next one is the or statement. So we're gonna solve this. Let's solve each one separately. Basically treat it like 2 separate problems. So we get x is less than -2. And I'm here, graphed already. Here's -2. We're going to the left. Then let's graph the other one. Or x plus 2 is greater than 6. So we're going to subtract 2 from both sides. X is greater than 4. So here's 4, open circle, and we're going to the right. And there you go. Remember, it's an or statement. They tend to look like this. Not always, but most of the time. As and statements tend to look like this. Again, not always, but most of the time. Next, number 9. Same idea, we're just going to solve it. Boom, boom. Let's get rid of that 3. So +3, +3, +3. I get -3 is less than or equal to 3x is less than 12. And then divide by 3, divide by 3, divide by 3. -1 is less than or equal to x, which is less than 4. So we're going to do the same thing. My lower bound is -1, which is a close circle this time. And my upper bound is 4. By the way, this is a closed circle and an open circle. We actually call this the ClopenSet, hence my name. Okay, section F. Absolute value equations. So remember the way you do absolute value equations, you have to, there's 2 steps. Step 1, or 3, I guess. Isolate the absolute value. Step 2, split. So the absolute value should have 2 answers, generally. And 3, we solve. So that's how we're going to do absolute value equations. Isolate the absolute value, split, and solve. Okay, that's the first one. It's already isolated by itself, so now we're going to split it. X plus 4 equals 9. You always do one that's exactly the way you see it. And then you do one that, like I say, is negative. You change the sign of the answer. Not the absolute value, leave that alone. Change the sign. X plus 4 equals -9. And then you just solve each one. So -4 minus 4, x is equal to 5. Or -4 minus 4, x is equal to -13. So either one of those 2 works. Over here, now, remember step 1, isolate the absolute value. So I gotta get rid of this -3. The 2 doesn't really matter, but the -3 I gotta get rid of. So before I split it, I gotta get rid of this guy. So we're gonna add that to both sides. +3 plus 3, I get 2x minus 1 is equal to 10. And then I'm gonna split it here. It's just easier. So 2x minus, parentheses x minus 1 is equal to 10. And 2x minus 1 is equal to -10. Now again, it's a little nicer if you just divide by 2 first. It makes it a lot easier. But people tend to freak out, so I just kind of do it here. Maybe the next one I'll do it the opposite way. Anyway, from here I gotta solve it. I am gonna distribute. So I get 2x minus 2 is equal to -10. Again, you could always, it would have been a lot faster if we just divided by 2 right here, but come see right here we're gonna solve. So +2 plus 2, 2x equals -8. Divided by 2, divided by 2, x equals -4. Over here, we're gonna have space. 2x minus 1 is equal to 10. Divide both sides by 2, you get x minus 1 is equal to 5. And then I gotta add 1 on both sides. Duh. So x equals 6. So those are my 2 answers, 6 and -4. Again, with absolute value, you mostly get 2 answers. Sometimes you get 1 if it's a 0, and sometimes you get none. But most times you should get 2 answers. And speaking of none, look at this one. Absolute value equals a negative. That cannot happen. Not possible. Absolute value is always positive, so it's not possible. You just put no solution. You're good. No way to make this happen. Okay, the next one here. So we could solve this one for 7 let's get rid of this 3 this time. Again, you could split it right now. You're good to split it. I'm going to divide by 3 first this time, just to make it a little easier. So x minus 4 is equal to 7. We still have the absolute value, so now we got to split it. 1 exactly the same. 1, you change the answer. So x minus 4 is equal to negative 7. Again, change the answer only. And then you just solve each one. So plus 4, x is equal to 11, plus 4, x is equal to negative 3. And there we go. Let's move on to the last page of the study guide. I'm going to do some short responses. So this first one, these are like the okay, deeper level thinking questions. How can you tell whether an equation with variables on both sides has one solution, if only many solutions, or no solutions? Once the variable cancels out. So once the variables cancel out, one solution, well, if it's one solution is going to be like x equals 2. The variables won't cancel out. You will get a solution. So that's how you do one solution. How can you tell? It's when the x's are different values. Because that means that you're still going to be left with an x. You're not going to cancel out. So x are different values. So that's how you tell. Infinitely many solutions, you get a true statement. So after the x's cancel out, you're going to choose a true statement. Something like 2 is equal to 2. Something true. 12 is equal to 12. Something like that. No solution happens when you get a false statement. So again, all the variables canceled out, you're going to get a false statement. Something like 2 is equal to 5, right, which is not true. So you're like, oh, no solution. So that's how you tell. If the variables cancel out, if it's true, then it's infinitely many. If it's false, it's no solution. And if they don't cancel out, then you get a solution. So it's one solution. Okay, explain why we flip the inequality sign when multiplying or dividing by a negative number. Use the example 2 less than 5 as an explanation. So we're just going to use that example as our basis. So if I multiply this by everything by -1, which is you're allowed to do, you're allowed to multiply both sides by negative or by the same number, I'm going to get -2 and -5. Well, if I still had it like this, that would be wrong. Right? -2 is not less than -5. On a number line, right, these are the bigger numbers. The higher you go, going from left to right is bigger. So the more you go on a number line, the more you go to the right, the bigger you are. So -2 is not bigger than -5. You don't want to owe $5. I'd rather owe just $2. So you have to flip the inequality. Something like that. Basically, when we multiply by a negative on both sides, it flips it across the 0 sign, which changes what's the bigger number. So that's why you have to change the inequality to make it work. So that's the general idea. Multiply by negative, you flip across 0. But across 0, the rules are different there, right? Bigger numbers are less. So if we have to change the inequality to make that work. Okay, let's do deeper thinking or analysis. A student solved 2 times x plus 3 equals 2x plus 6 by dividing both sides by 2. Getting x plus 3 equals x plus 3. They wrote x plus 3 as the answer. Explain what x plus 3 equals x plus 3 actually tells you about the solution. So they did the math right, the first part right. They divided both sides by 2, you would actually get x plus 3 equals x plus 3. But we know that x plus 3 equals x plus 3 is actually infinitely many solutions. That when we have this, the variables could cancel out. So we subtract both sides by x, you get 3 equals 3. So this actually tells us the variables cancel out, which gives us 2 options. Either infinitely many solutions or no solution. So anytime the variables cancel out, you only have 2 options. And in this case, we have a true statement, so it's infinitely many solutions. So that's the idea there. Okay. Next one is explain why the compound inequality x less than 2 and x greater than 8 has no solution, while x less than 2 or x greater than 8 has infinitely many solutions. Use a specific number expression to show how it works. Well, let's actually just graph it. So here's 2, and if I say x is less than 2, that's going this way, and then here's 8, and I say x is greater than, that's going that way. So why does and not work? There's no overlap. There's a number that's both less than 2 but greater than 8. So that's why it works. No number is less than 2 but bigger than 8. Right? No number fits that criteria. No number can fit that criteria. But or it's very different. As long as it works for one, it works. That's your answers. Like I could walk to work or I could take the bike to work. As long as I do one of the two, I'm not lying. It's true. So same thing works here. If you're long your number that's less than 2 or greater than 8, that's a solution. So for example here, I could say, what if x equals 10? 10 is greater than 8, so it works. So for or, as long as it works for 1, it's true. So in that case, you have infinite many. Anything that's bigger than 8 works, that's infinitely many there. Anything less than 2 works, infinitely many there. So that's why. Okay, last one of these types. Explain why x minus 4 equals 86 has no solution, while x minus 4 equals 4 has exactly one solution. Use a definition of absolute value to tell why. So in this case, remember, this is how far from 4. So like the number line here, this is 4, it's this guy. And this is saying you're negative 6 away from 4. Like, what does that mean? If you're 6 away, you're 6 this way, you're 6 that way. How are you being negative 6? It just doesn't make sense in this idea. So you can't be negative 6, not possible. You can't be negative away. It's a distance, it's always positive, so not possible. While this one says you're 0 away from 4, which is 4. That's 0 away from 4. So my answer here is x equals 4, because that's 0 away from 4. Well, the answer here doesn't make any sense. You can't be negative 6 away from 4. It doesn't work. So even going back is 6. It's a distance. So that's the general idea. Then these are just little self-checks, so you can check you can ask yourself if you know this, because if you don't know it, make sure you know before the test. Anyway, that's the video.